Math 1343, Week 8, Video 6, Goodness of Fit Test P-Value Approach. At the end of the previous video, I said that we're going to do one more video where we take a new Goodness of Fit test from beginning to end. And I'd forgotten that I wanted to do the P-Value approach on the previous test. I'd already erased the entire board, so I just put up the stuff that we need. So if you're wondering where all this stuff came from, I recommend watching video 5 in this series and possibly the videos prior to that. But without rewriting the entire problem up here. For the p-value approach, we start the same by stating the hypotheses, which I do have both versions of them. I have the hypotheses in terms of what the proportions are equal to. Remember, the null always says all of this, and that. Whereas the alternative says no, or no. And you can also write the hypotheses contextually using words. Null hypothesis being the company's claim is correct, and the alternative simply saying no, it's not. We did calculate the test statistics, so I'm not going to rehash that. It was 8.6667. Remember, if you're doing the p-value approach, you don't calculate a critical value. You go right to the test statistic, but then you follow that with the p-value. The p-value is the area of the tail or tails cut off by the test statistic. This is still a right tail test. A goodness of fit test will always be a right tail test. And since our test statistic was 8.6667, we would sketch a chi-square curve, still have degrees of freedom equal to 4, and cut off a right tail at our test statistic of chi-squared equals 8.6667. But the problem with doing the p-value approach when you're using a chi-squared table is that the chi-squared table only has 10 different areas on top. And in each row, there are only 10 different values of chi-squared. So the chance of you calculating a test statistic and finding it in the correct row, I've written just the 4th row of the table up here. The chances of you finding your chi-squared value in there are slim to none. So just like doing the p-value approach for the t distribution, to do the p-value approach for the chi-squared distribution, you don't get an exact p-value, but you get a range of p-values. How do you do that? Well, you go to the correct row, which was 4 because of 4 degrees of freedom. Then you scan across looking, for your test statistic, which again probably won't be in there. So you look for the 2 values that your test statistic is in between. Moving across, we see that our test statistic of 8.6667 is between these 2 chi-squared values. 7.779 is less than our test statistic, and the next one, 9.488, is greater than our test statistic. So our test statistic is between these 2 chi-squared values. What that means is our area, our p-value, is between these. So the best we can say about this area, the best we can say about this p-value is that it's greater than 5% but less than 10%. And we can write that by saying that 0.050 is less than the p-value, which is less than 0.100. So what does that do for us? Well, even though we don't know the p-value, we can still compare it to the significance level. I didn't write it up here this time, but we are using a significance level of 5% still. We don't know what the p-value is, but we know that it's greater than 5%. So even though we have a range of p-values, we still know that the p-value is greater than 5%. Because it's between these 2 numbers, which means it's bigger than this one, so it's bigger than 5%. And remember, when your p-value is greater than your significance level, that means, therefore, you reject the null hypothesis, just like we did before. Had our significance level been 10%, then we would have not rejected it because our p-value, I can't believe I just said that. Do not reject the null. Oh my gosh, I'm so sorry. Do not reject the null. You reject the null when your p-value is too small. This one wasn't. This one was bigger than 5%. Had our had our significance level been 10%, then we would have rejected the null hypothesis because our p-value would have been less than 10%. So if/when I ask you to do the p-value approach, just remember, you're probably not going to find a p-value because your test statistic probably will not be in the correct row based on the degrees of freedom. So the next best thing is to find the two chi-squared values that it's between and say that your p-value is between these two. Then you should be able to compare it to your significance level. And by the way, these numbers up here are typically your common significance level. So therefore, if your p-value is between some of them, you should be able to draw some conclusion like I'm bigger than this or I'm less than that.